Okay, stream time. As an intro, we will watch glass exploding at 343,000 frames per second. It takes a little bit. It's from the slow-mo guys, it's pretty cool. It's just one glass thing breaking. One Pyrex dish or something. It's nice how you can upload almost 20 hours to YouTube. I think even mere mortals can upload long videos. Not sure about 20 hours, but a few hours are no problem. Okay. Observe the smiley. Good morning, William.
Good morning, William.
I'm not sure it's the right face for a British butler. Somebody should make a new face. Okay, back to the AI. I solved the problem we had yesterday with the backtracking and everything. How to add backtracking to our logic engine. And the idea to solve it is to have two modes. It's called want alternatives. We need different modes to run a program. So this program for the last time, we'll make a new program today. I think I've seen this too often. This kind of program you can either run it step by step, just like a normal programming language like Java or C++ or Basic or any other one of that kind. You just run it step by step, one line, one line, one line. And one other mode is to explore every option. Here there are different solutions for X. Here there are different solutions for Y, so you explore all the options in a tree. That's usually called backtracking. And there can be more modes. You can mix this. You can explore some options, throw away some other options. There are different ways to run programs of this new natural language kind. So here in the native predicates in the Java part, I just added this choice of do you want alternatives? And if yes, we provide alternative solutions. This list does the same thing. Either just one random value or the whole list. And implemented is only one of the modes. The imperative mode is implemented. Also, I shortened it a little bit. I extracted some procedures. Parse Python-esque procedure. This is a new include. And you know, it parses things with colons and indentation and if and while and for. So we could work on this backtracking thing, but it's pretty complicated still. We can do some other things. How about we test our engines? We make a test script. And how do we write a test script in our new language, of course? We use our new language program. What do we have? Counter. Counter in philosophy engine, that sounds perfect. Here. This would be one program. We are still making up language. I just use this here for a change. I don't know. Or maybe you want this. It doesn't matter really. Program. Should end with oops. should end with I equals 100. This, however, this is a Java expression now. We are still mixing all of this. So this is our test script. And this does not specify the engine we use because the engine is what we want to test. How about we make a new how about we make an actual testing module? Test philosophy engine. Dun, 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 dun. So we also have a program, and the program here is to test the other programs. This, right? It's another level. It's a program in a program in a program. So this means do something when the module loads, but do it in a different thread and don't stop anyone else. If you have really urgent stuff to initialize and other modules depend on this module, you do it here because this is done before the module is declared loaded. So for my clients here. But this is a module that just stands on its own, so it doesn't even matter. Also, what we do could take a long time. We are testing logic engines that might not be done in half a second. So we start a new thread and it runs in the background. We have multi-threading, of course. Okay, so now we need to find a logic engine, because each of these natural language programs, we need a name for this language, I guess. Super Prolog. Super Prolog. We need a name for this language. Name in flux. Okay, lost track. So for each of these programs we need an engine to execute it, and these engines do differ still. The engine we need here implements these two native things, which are not part of the core language. So, okay, first we need to parse this program here. We just make another philosophy engine. Tester. Or main, what? I don't know. Main maybe? Main.program is program. And we can just call run. And now we have effect, I think. Let's see if we have oh, I did not save in a new. I was stupid. Okay, that was really stupid. Philosophy part 1. Yeah, now we have this source code in the. That was stupid. Different ways to resolve it. We can duplicate here, fix this one first. Test philosophy engine developing. We got this covered, and here the undo should do the job, right? If I undo frantically, I think we have unlimited undo. Yes. We are back to the actual. Why does it say changes? This is kind of funny. What are the changes here? Changes. Oh, because I saved the. Yeah, I see, no problem. All good. All restored. So this did, what did this? Did it transpile? Wrongly defined class. That should do it. Yes, okay. Look at that. Okay, it isn't really, yeah, okay. It is actually confused. Yeah, because it splits at empty lines first, and there's an empty line here. And so it breaks apart the structure here. It's another low-level thing we have to do. Do I have a token enabled split at empty lines function? Naturally, I do not. Maybe I can fake something together here. Someone has to make these basic things. You know, the legwork of AI. Oh, this was. If nobody does the low-level stuff with strings and characters, we have no AI. So it has to be done. Token aware split it at empty lines. I'm very precise with the tokenizing and parsing and everything because it's the foundation. So we go through the tokens, and if like this, we'll make a regular expression, right? Because we have these crappy. How's it going again? How is it done? This, right? DOS or Unix backs new lines. Jesus Christ, I can't talk. Regular expression for new line. I believe it's that \r optional. Rn here, N or Rn, see, and with the question mark, right? Split a token in license. Is that what we want? I think not. This throws away some token. Yeah. Okay, let's think about it for a moment. We need to go through the non-code tokens, and we will not split in the beginning or in the end, because that doesn't make sense really. Nothing to split off there. So if we find double new line, here actually space, optional spaces. Yeah, that should be it. Then we split here. Not so easy. Not so easy. Okay, we have some output. Return the output. And it's the usual business. I've done this kind of stuff before. In another video even. Okay, we found this kind of split thing. Yeah, okay. Join. Yeah, okay. We will keep all the line breaks for now. All the spacing, because the client might need it. Start. No, we need the exact position. We need the position. Okay, yeah. Where is the line break in the thing? Index of regular expression. Index of regexp. Case insensitive, but that's kind of wrong. Let's make another one. Some basic tokenization work. Let's start it. This is the same thing without the case ignorance. And which way around is it? Pattern last. All right. Is it all running? It is. So okay, trims each item. Maybe this. No split point found. And we found a split point, so we write if it's yeah, it's okay. Yes. And start. It's annoying. You need to split. Oh man. Need to remember something here. It's annoying. Okay, I think I can do it. Index 2. No, it's not exact. Start with that. This looks rough as heck. This looks totally and utterly rough. Also, it fails to transpile. Invalid escape sequence. It's true. I did not add my new standard function. Now I did. Okay, it transpiles, but is it working? Ha 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 ha. It's now called Smart Parser 1. Smart Parser 1. The thing that parses almost everything. Okay, this is a breaking change if we add this here. And we mark breaking changes with a very useful comment. Don't we? All right. Ouch. Hello? Okay, can we split this here properly? No, we cannot. Oh, it's the usual problem with this kind of loop. In the end, you have to do the final step. If if start less than yes. It's very smart to have an untested function in live code. That's always really smart. Okay. Let's see if the other stuff still works. Another fact goes here. Yes. There's the comma, 2 entries. Okay. So that finally works. Retranspile and bada boom. Super prologue, isn't that good? Okay, it found the first facts. The fact about this program and what it should do. So let's assume we just make a native, that's one way of doing it. Add native predicate, program X should end with Y. Okay. X program and end condition is then Y. Let's print them quickly to see if we are here. And then do we return? Yeah, but no. Okay, slight problem. It's not a native predicate per se, it is we want to make a logic rule, I think. Because this up here, it counts as a fact. The engine has rules and facts. So we could do something once on all the facts we have right now, which is only this one fact. Okay, yeah, okay, why not? On fact. Fact. Let's make something generally useful and very simple. The philosophy bot just gives us list facts matching. And we get the variable map. List facts matching x. X and y are the variables. That's just a global thing. And we just make this little function here. Okay. List facts matching pattern. Pattern contains x and y, etc. We return a list of variable mappings. And the code we need is somewhere here. On native predicate. Here we do the same thing. We zip with the head of the predicate. And we do this to get rid of the round brackets. And that's pretty much it. Zip it. How often do we call this? Here, we do it here also. Here it seems we do not throw away the brackets. So yeah, sometimes we throw away the brackets, sometimes we put them back in. Okay, no problem. We need the zip it pattern. Go through all the facts for now. It's not optimized, I know, it doesn't matter. For fact in facts. And we have this ping here. Ping means make everything interruptible. JavaX modules have certain behaviors. They lend themselves to interruption at basically any point. Because we have many modules in one Java VM, the whole OS is one Java VM. And we need to cleanly unload modules inside a Java VM. It's like another magic trick that is considered hard, but I basically did it with the source code rewriting, or with a transpiler basically. Now we can iterate over facts using a pattern. It even transpiles, and we should test it right away. Okay. I'm pretty sure I just, yeah, bad hygiene. Listen, I mean, I should make these red. Why do I not read my own error messages? Right here on the screen. This true is of course nonsense now. Okay. Okay, down here we are. There's the program. End condition. So this is getting fun now, because basically we have to build a program here, compile it, and run it. So this testing framework here should create little programs, run them, and see if they work. Because somehow we need to get this, for example, this is a Java condition. We need to get this into the Java engine, but this is in a string, so we need to compile and everything. We just jump around the levels. I'll have to do that. Go to the source level, make some source code, load the source code, execute some stuff, go back to the source level. That's pretty much what AI will do a lot. Make its own programs and run them. So, okay, we need to find, yeah, let's make it a little simpler for now. With engine, and we put the address of the engine in there. Or native predicate. All we basically want is this here, this, and the variable, and yeah. Let's do something elegant. Okay, let's mix Java and, yeah, it's always okay. No. Let's just collect. Oh yeah, this will be nice. Okay. We just mix all the languages just as we please. And init code. Here, check out this. This is going to be good. Okay. This is one sentence now. Program something with declarations something and init code something should end with some condition. Not sure how to format it perfectly. So, and from this long English sentence with embedded code in 2 different languages, we generate a bit of Java code or JavaX code and run this code, just to show you that it's really possible to generate code on the fly. Let's quickly check the parsing. It will not match this. Okay, the whole thing is one fact. That's okay. Here it doesn't match anymore because we have a longer sentence to deal with. Program with declarations. And we should have more variables. Right now we're limited to x, y, and z. Okay, it contains. We need more variables. Also, no. Where do we even use this whole word? Only once here. All keys are in set. Okay. Is variable. Either it's in the list of variables or it has a certain pattern. We want to make unlimited variables, right? How about this? And let's make sure it's not null. Okay. Something for now. All keys. We want a predicate here, right? I think I have this all. I have an all function, which means does a predicate hold for all elements? Pred. Is it a variable? Let's make the full method signature here. It's a function from A to bool, and are we going to optimize it right away? Yes, we are. If any of these returns false, it is false, and otherwise it is true. If all keys are variables, we say it's an OK mapping. So far, so good. All keys, brackets. Okay. Program var p with declarations var d. It's super ugly, isn't it? Should end with. We could introduce this $d. Let's see. And init code ri should end with. And we can just use a multi-line thing here. Should end with var c for condition. How about we make it really pretty? That's our pattern. Huh. Now we have new variable names, map. Let's see. Declarations. And init code. Yeah. now build some Java Xcode. What do we have in our program? It should in the end look like this thing here, maybe without the framework around it. So first we do the declarations, line break to be sure. This works, right? Oh, join with empty lines, that's good. Join with empty lines. Yep. We put the declarations first. We need to make the bot. Screw the transient stuff. And program. Then let's say we make some function, or some main function. Bot program equals quotes. Now we make making code to automate testing the logic engine. Program. Then the init code for the engine and end condition. And then something like assert true end condition. And then we end the main program. Print indent JavaX. Okay, we have code making code. Oi, look at this. This is the code of our code made. Variable declaration, new bot, main program. Set the program in the bot. Yes. Add the native predicates. Ignore the indentation, it doesn't matter. Assert true, and we're done. Now we do the drum roll. Do the Java X super magic. You can just say hotwire. Or can we? I think we can. Now we can call the function we just made. Call main. We assert succeeded, so we're good. Program works. Test succeeded. Let's check it out. We are not seeing exceptions, which is stupid. There are no exceptions. What's happening? Oh no, there is an exception. A hot wire is maybe not the right function. Java eval. Let's see how the Java eval does the job. Eval Java prep. How do I evaluate Java code in JavaX? This just calls the function. Here, very quick Java is. Okay, I must have used this slightly wrong function. Hotwire takes a program ID, but what we want is to supply the program text directly. Running translator. It is doing the thing. I have to compile, that makes sense. It means there is no pre-compiled version of the thing. And we get the errors here, which is annoying. I really should fix that. The errors should also go in here. That's just stupid, I'm sorry. But, okay. Yeah, we are just, we're almost there. It's just about whether fields are static or not. Yeah. Let's go static for now. Code making code. I never get tired of it. It's translating. No error yet. Okay, the same thing. The other field is also not static. I can never decide whether to go static in Java or not. I mean, yeah. I do static too much, maybe. But it's fast. You know it's fast, so that's good. Compile, compile, compile. Okay, almost. It says, did we even start the bot? Here's the code we made. Add native predicate. Oh, we didn't even run the logic engine. That is, of course, wrong. Init code. Bot.run. I believe that might be it. Transpile level 1 done. Run transpile level 2. Test succeeded. Oh, that's pretty good. Still no rename function. Auto test philosophy engine. So we use the engine itself to test itself. I'm already happy. Job done for today, I'm sure. Oh, it's transpiling again. It's reloading again because it, I don't know. I don't think I changed anything. I just renamed it. Why does it? Oh no. It believes I changed something. It loads the module again. Runs the test again, and the test succeeds again. And let's finally correct this bracket. What did we do here? 43. Oh, yes. It ran anyway. Here, this is how we can write our tests from now on. With English. Other stuff we could do. Oh, what I really want is speech recognition. Speech to Discord.
Speech to Discord.
Oh, you're having echo, I think. Plug in. Oh, I did it all wrong in terms of streaming. Also, the phone is too close. Ah, that's stupid. Beginner mistakes.
Beginner mistakes.
And this is a little annoying. Showing the Java window. Overlay text. Big overlay. Top input, big overlay. Top input to big overlay text. Tip bot. It's the bot that shows this big text. Huge text. Usually it works, but sometimes, because this is like a half transparent window, or a window with unusual outlines, Java does some nonsense. Maybe we can fix it quickly. Waterline centered. Center window. I think I show the window first, then I center it, so that's where all the confusion comes from. The window starts out up here, gets filled and shown, and then moved. So we should try to move it first. I don't think there should be a problem. We have the shape and the size we need. Here, yeah, that's of course stupid. Let's make a backup quickly. Backup with old execution order. And let's try and fix it. Make a new window, always on top is okay, but we can also do that later. We do all the stuff, we center the window, we set the shape, and then now we show it. Is it reloading? Top input. I think it should have reloaded. Let's be really sure. We do it. Good morning.
Good morning.
Okay, now it doesn't work anymore. That's great. What's up?
What?
Okay, no, that was not good. Okay, exception. New text layout, yeah. Text layout, okay. Here, we need the window to calculate the text sizes and everything. I guess. And that doesn't work when the window is not showing it. Ay, that's so annoying. Ugh. Sadly, that did not work. Oh, yeah. trying to get rid of background bug, but causes null pointer exception. Too bad. Let's restore the old version. Text, paste it here. Okay, so now we should have our overlays back, including the occasional bug. Okay. Are you back? He's back.
Are you back?
Discord speech. No, nothing found. Let's make that. Let's make a Discord bot that posts when I speak. That's gonna be hilarious. Look at this host of Discord applications. Dr. Asimov. It's a new bot. What? It is a bot already. Copy token. And let's create it. Oh, I need the token later, right? I'm stupid. Okay, this will be the token. And create a new bot. New text. See, speech to Discord. A usual base class. And user utterance. User utterance. Exactly. Sock puppet, is that the same thing? Similar. No relation to Discord. Oh. Here, this is how easy it is. Repeat every speech input if it's not the same as what we just heard. Don't know why I did that. Okay. On user utterance. This is how elegant my operating system can be. This is just source code for a whole bot. So, okay, what kind of bot is it? Is it a talk bot? I guess it is. Why not make it a proper bot with all the latest features? Okay. We need like a preferred channel. It needs a channel to post in. So, for all intents and purposes, it is similar to other bots we have, like the Great Greeter bot. Prefer this channel to greet in. Preferred channel ID. I think we can get away with this. No. What was a really short way to make a bot? Standard bot 1, I think. Yeah. Standard bot 1. So, even shorter. Standard bot 1. Speech to Discord. Yeah. All servers. Yeah, which server, which whatever. Oh. It's overkill for now. Now we make bot that posts my speech to Discord. It's overkill to have this bot be aware of multiple Discord servers. For now. I don't want to spam multiple Discord servers with whatever I say, I guess. So we can use a simple base class here. Discord hopper. That's our older Discord base class. Okay. Done with this. Post in channel preferred channel ID. I just need the posting part to Discord. I mean, having this last variable here for the last thing said is pretty elegant, because if the event gets distributed twice, if we get the same speech event twice for whatever reason, we will post to Discord twice. That's just uncool. And this fixes it. 5 seconds as a window. Okay, I didn't save, so speech to Discord. Speech to Discord. Okay. Load the module. Now we need the token. Copy token. Token. Reload. Oh, bot not invited, I'm pretty sure. Invite the bot. I'll give my bot voice permissions now. Never use it, but why not? For the future. Have some talking bots. There we are. And I routinely add new bots to my bot-to-bot talk discords. Swarm AI and the Swamp. Both have the same purpose, basically. It's a place where bots can talk to bots. Welcome, Dr. Asimov. Not reacting to user. Now that sounds logical. Not reacting to yourself. Dr. Asimov's here. I just write something so the bot sees this channel. And knows to post here. It just selects the first channel where any activity happens and will post there. So let's try. Good morning.
Good morning.
See, we are posting to Discord. This is coming straight from speech recognition.
This is coming straight from
This
speech
is
recognition. This is
not Mrs.
not Mrs.
There you go.
There you go.
You can watch the video later.
You can watch the video
I'm just
later.
speaking.
I'm just speaking.
Wonders of technology.
Wonders of technology.
Okay, stream end.
Okay, stream end.